Assalamualaikum and good evening. We are from Group 3. We present the experiment 4, which is the application of first and second law of thermodynamics. And these are our group members. This experiment aims to expose students to the first and second law of thermodynamics. Two beakers of different sizes were used in this experiment. The small one was filled with tap water and the bigger one with cool water. The small beaker containing tap water was then heated until certain high temperature were reached. Then the small beaker will immerse into the beaker that contained the cool water. The temperature change every 1 minute was recorded until both beakers reached the equilibrium temperature, which is the constant temperature, where the hot water is 26 degrees Celsius and the cold water is 25 degrees Celsius. The constant temperature was recorded for 5 readings. In this experiment, one table was constructed to record the temperature change and a graph temperature hot water and cold water against time was plotted. Referring to the first law of thermodynamics, the summation of internal energy change is equal to 0. The first law of thermodynamics is known as the principle of conservation of energy. It states that energy cannot be created or destroyed. It can be transferred from one to another form. For the application for first and second law of thermodynamics is sweating. In a hot temperature room, the heat of the body will transfer to sweat to cooling down a body. Below was the equation related to internal energy, work done, and heat flows. Ideal situation means there is no heat loss to surrounding. This is because the heat transfer only between hot and cold water. The second law of thermodynamics is about a heat flow from a body with high temperature to a lower temperature. A heat transfer can produce a work done in a medium. The application for second law of thermodynamics is the melting ice process, where the water will release off heat and causes the ice cube melt. The heat flows from water, which is the high temperature, to ice cube, which is the lower temperature. The objective for the experiment is to apply the first and second law of thermodynamics in various processes. There are 3 scopes for this objective. The first one is the study consists of energy change between cold and hot water until it reaches the equilibrium temperature, which is the 25 degrees Celsius for the cold water and 26 degrees Celsius for the hot water. The coverage of this study is the temperature change for cold and hot water within 1 minute until both reach the equilibrium temperature. The range is between 25 to 80 degrees Celsius. The third one is the study covered the amount of heat transfer between cold and hot water that affected the energy balance in this process.
Next, I will talk about theory. We all know first law of thermodynamics is about principle of conservation of energy. According to a physics professor at Missouri State University, Professor Saibal Mitra, the first law means internal energy of system equals to energy transfer plus or minus work done on the system. So basically, any type of energy that went in or out of a system is equals to difference in energy of a system. In this experiment, we consider it's an ideal situation, means there is no heat loss to the surrounding because heat lost by water is gained by cold water. Thus, the internal energy difference will be equals to 0. Okay, this is the general energy balance equation for closed system. Since there is no change in velocity, height, or work boundary, so there will be no presence of kinetic energy, potential energy, and work. Since we assume ideal condition, the difference in energy of system is equals to 0. Thus, our final equation will be addition of internal energy of hot and cold water equals to 0. Next, second law of thermodynamics can be expressed using Clausius statement and Kelvin-Planck statement. According to Clausius statement, in a cyclic process where the final result is transfer heat naturally from low temperature to high temperature is impossible without work input from device such as heater and heat pump. If there is heat transfer from low temperature body to high temperature body, then according to Kelvin Planck statement. Part of heat is converted into work. Work is needed to transfer heat from low to high temperature body. That is because heat transfer is always have increasing entropy.
So for the experiment setup, in this experiment, these are the apparatus that we will be using. The first one is the electronic scale, hot plate magnetic stirrer, large 1000 ml beaker, small 100 ml beaker, a glove, two retort stand, and two thermometers that have both negative 10 degrees Celsius range and until to 150 degrees Celsius.
For the methodology, the first step, the mass of small empty beaker is measured using electronic scale and recorded. For the second step, mass of a big empty beaker is measured. For the next step, the big beaker filled with tap water and ice cubes to make cold water. For the fourth step, the small beaker is filled with tap water. Step 5, the mass of small beaker filled with tap water is measured and recorded. Step 6, a thermometer is clamped by retort stand. Step 7, the small beaker filled with tap water is heated using hot plate magnetic stirrer until 80 Celsius. 80 degrees Celsius. The thermometer is used to measure the temperature. For the eighth step, when the temperature reach 80 degrees Celsius, the thermometer is released from the retort stand. Next, step 10, the beaker is transferred immediately from hot plate magnetic to electronic scale using gloves. Step 11, the mass of beaker filled with hot water is measured. Step 12, the heated small beaker is placed carefully into an empty big beaker. Step 13, the ice cubes in the cold water is taken out. Then, the mass of the cold water is measured. Step 14, the big beaker is filled with cold water until it reaches same level with the hot water. Step 15, both hot water and cold water is measured using two thermometers respectively. For the step 16, both thermometer readings are recorded with the time intervals of 1 minute each using the stopwatch until both water reach equilibrium. Step 17, when the experiment ends, all the apparatus are cleaned and returned to original state.
Result and discussion. The result of time, temperature of hot water, and temperature of cold water is recorded in Table 1. The temperature difference of hot water and temperature difference in cold water is subtracting final temperature with initial temperature respectively. Next, we have calculated the mass of hot water and cold water. The energy change in hot water and cold water is calculated by using formula mc theta. Graph of temperature of hot water and cold water versus time is plotted. While conducting experiment, we observed temperature of hot water started to drop drastically from 0 to 4 minutes and then slowly decreased by about 1 degree Celsius until 26 minutes. On the contrary, temperature of cold water has been rising rapidly from 0 to 4 minutes and then slowly increased by about 1 degree Celsius until equilibrium is achieved. From this graph of temperature of hot water and cold water versus time, it shows that when the time increases, the temperature of hot water decreases while the temperature of cold water increases simultaneously until the temperature is remain constant with more than 5 consecutive temperature readings. The first law of thermodynamics, known as the principle of conservation of energy. The heat released by the hot water will be absorbed by cold water under ideal conditions. The changes of temperature between hot water and cold water will continue until they reach a thermoequilibrium. For this experiment, the thermoequilibrium reached around 25 degrees Celsius to 26 degrees Celsius. There is no heat transfer at this movement. Although the heat released by hot water will be absorbed by cold water, but it does not mean that all the heat energy will be absorbed by cold water. Some of the heat is lost to the surrounding as the heat may be lost through conduction, convection, and radiation. In this experiment, we can see that there is heat loss to the surrounding through calculation by using the equation of hot water of mc theta plus cold water of mc theta equals to 0. Because the hot water release energy which is exothermic, the energy change of hot water at 26 minutes is minus 19.046 kilojoule, which shows a negative sign. The cold water absorbed energy which is endothermic. The energy change for cold water at 26 minutes is positive 21.273 kilojoule, which shows a positive sign. Hence, the difference between total energy of hot water and cold water, which is 2.227 kilojoule, has already proven that the heat has been lost to the surrounding in this experiment. The energy will not be destroyed, it will only change a form and exit in different forms. Moreover, in second law of thermodynamics, it can be explained as heat energy only can transfer naturally from a hot body to a cold body. In this experiment, the temperature of the hot water keeps dropping from 80 degrees Celsius to 26 degrees Celsius, and the temperature of the cold water keeps increasing from 9 degrees Celsius to 25 degrees Celsius. We observe the temperature at 20 minutes for both hot and cold water remains same, which is 26 degrees Celsius for hot water and 25 degrees Celsius for cold water till 26 minutes. Since we obtain more than 5 consecutive same temperature, thus we assume thermoequilibrium is achieved.
So, for our conclusion, to summarize, in this experiment, thermal equilibrium is achieved when both hot and cold water reaches the same temperature. And so the energy change in hot water is negative 19.46 kilojoules, while the energy change in the cold water is positive 21.273 kilojoules. So the negative value of energy change show that heat is released. Also, it's an exothermic process, while positive value shows heat is absorbed, which means it's an endothermic process. So both hot and cold water reaches thermal equilibrium at around 25 degrees Celsius to 26 degrees Celsius. So the first and second law of thermodynamics have been applied to this experiment and have been proved. So what is our possible errors? So our possible errors is maybe the inconsistency in temperature reading due to heat loss to the surrounding area, which caused by environmental factor. Also, an inaccurate reading of the temperature of the water, as the thermometer are not placed at the center of the solution or water. So what improvement that we can make? So the first improvement we can make is to make sure the room are in suitable condition before starting the experiment by turning off air conditioner, fans, and closing the windows in the lab to make sure the room temperature and the humidity are suitable for us to take place the experiment, for us to go through with the experiment. So the second improvement is to place the tip of the thermometer inside the solution and are not placed to the wall or floor of the beaker, as the temperature of the beaker and the solution are not the same. Next. Now for the safety and precautions. So for laboratory safety, first tie back long hair if you have long black hair, and avoid wearing loose clothing or jewelry that could caught in any equipment. Also in the lab, please wear appropriate personal protective equipment or PPE for short that include lab coat, glove, and closed-toe shoes. Next for the equipment safety. So the first equipment safety, avoid touching the beaker during the heating process. And then we should avoid touching the metal surface of the hot plate even after heating process is finished. Lastly, clamp the thermometer tightly and securely to the retort stand to avoid it falling off. Last is the reference. This is the reference that we use in making our lab report.